Hi guys, how do you feel?
Great.
Everything
Thank
fine,
you.
thanks.
Nice. Artur, so how long do you do machine learning?
It's about 1 year. Mostly it's just for fun. Yeah.
Okay, that's nice. You know, I always think that if my lovely front end would suddenly come to the end, I would definitely switch to machine learning and artificial intelligence. Because I think I think artificial intelligence is the future. And do you think that AI will rule the world?
Well, maybe. I think in future we'll be having some sort of hybrid government. I mean, people will work together with machines to provide the best they can do.
And why are you so sure it's not doing it yet?
Well, sorry, could you say it again?
Why are you so sure? I was mostly asking Lena, but you too, that AI is not yet ruling the world.
Well, I think it rules to some extent. It helps to analyze a huge amount of data. Helps, say, CIA to intercept some traffic, to analyze data, and so on. I think, yeah, does what it's supposed to do.
Okay. You know, guys, I think that the combination of these words like machine learning and JavaScript are a huge field for jokes because JavaScript has dynamic types and not the biggest stability. So what do you think about this?
Well, I think JavaScript here is like a glue code, allows us to connect the hardware accelerated computations. Say you can embed anything, almost anything inside your browser. Say, for example, you can use WebAssembly to do the computational things really well, or WebGL. I think it works great together.
From my point of view, I'm mostly making JavaScript code work just by swapping the code back and forth, changing its places, and as far as I know, machine learning mostly works in that way.
How about TypeScript? Does it work with TypeScript?
Sure, TypeScript is a superset of JavaScript, as they usually tell us.
But is it harder to make it work with TypeScript?
I think it's equal. The same that works on JavaScript should work on TypeScript as well.
Okay. Guys, do you remember this Rick and Morty episode with this songs contest between planets?
Yeah.
Yeah.
So, show me what you got.
Oh, yeah. Well, hey everyone. Well, it's not a secret that 21st century has become the century of information technology, where automated data processing, in particular using machine learning, plays one of the main roles. So, a few words about me. I have more than 6 years experience in web development. I'm mostly specializing on JavaScript development lately in conjunction with machine learning, plus do some DevOps and quantum computing as a hobby. Apropos, if you want to learn more, here is my GitHub profile. There, I just have fun doing some researches and prototypes for myself. Well, let's see what the interesting information you'll see on today's machine learning talk. First, we'll start from what machine learning is and how it basically works in most cases. Secondly, we'll take a look what is already available in machine learning JavaScript ecosystem and what to do if something is absent and needs to be ported from pre-made Python implementation without rewriting to JS. As an example, we'll see what's supposed to do sentiment analysis in conjunction with machine learning and what business value it can have. Then I'll show you how to use neural networks for sentiment analysis inside the browser environment, and we'll see how it works on Instagram comments. Fifth, we'll dive into the inner implementation of this tool, and in the end, we'll sum all of these good things up, and I'll give you possible paths for further readings and so on. Well, let's get into it. What is machine learning? Basically, it's a branch of what is called artificial intelligence, mainly focused on building applications that learn from data and improve their accuracy over time without being programmed to do so. Well, there are many branches, but the most major are the following. First of all, it's reinforcement learning, when computer learns to behave in an environment where that rewards its actions with positive or negative results. Secondly, it's supervised learning. Well, it's defined by its use of labeled datasets to train algorithms to classify data or predict outcomes accurately. Supervised learning helps organizations solve for huge variety of real-world problems at scale, such as classifying spam in a separate folder from your inbox. Unsupervised learning uses machine learning algorithms to analyze and cluster unlabeled datasets. These algorithms discover hidden patterns or data groupings without the need for human intervention. Its ability to discover similarities and differences in information make it the ideal solution for exploratory data analysis, cross-selling strategies, customer segmentation, and image recognition. So, a few words about how machine learning actually works. First things first, we select and prepare a training dataset. Secondly, we are choosing an algorithm to run on a training dataset. Then we perform the actual training to create a model. And finally, we are using and improving the trained neural network. As an example, let's take a look at how machine learning works under the hood in the project, which is called NanoNeuron. First of all, we prepare data for training here and testing our neural network using the true Celsius to Fahrenheit formula. And as a simple basis, I'm going to pick AX plus B formula for making predictions. And here is how it looks in graphic representation. Well, pretty basic formula for making predictions, but very useful for degrees conversion. Then, at start, we are just passing random weights as A and B parameters to the neural network. And then we start training. During the train phase, we are just adjusting the weights and checking the deviation from the true results. During the forward propagation, we are iterating through training dataset and calculate predictions cost, which is actually number representation from deviation from a true value. When we are stepping into backward propagation, we are just calculating deltas using the generated predictions and average deviation. So after this, we can adjust our weights using the calculated deltas. So basically, on each iteration, we are just adjusting the weights according to received predictions and cost deviation. Well, and then we are actually passing the input data to the function with more or less precisely adjusted weights, and as a result, we receive the prediction. And finally, the demo. As we can see, few steps. As we can see, after several thousand epoch, the accuracy gets better and better, and we are having more and more improved accuracy to our weights. And finally, we are most ideally have adjusted weights. Just a second. Oh no, once again. Sorry. Great. Oh, yeah. Oh no. Anyway, well, in the end, we receive numbers for A and B parameters, which are almost equal to 1.8 and 32. Okay, well, hey, dude, what's going on? Okay, now we know that any neural network is just a function with weights, but what about JS and Python? Well, let's find out. So, in what cases may JS be a good fit for us and why? First, it's a great ability to use on almost any device, JavaScript everywhere, which is very cool for every JavaScript developer. Secondly, it's a rich ecosystem and plenty of ready-to-use packages, and some of them even ported from Python. The great ability for integration with Internet of Things devices with using Web of Things frameworks. For instance, it can be Node-RED and some others. Offline support plus access to camera and other browser API. So, for example, you can use progressive web applications that can be easily installed on the user device and work even in offline mode. And if you know JavaScript, Python fades to second plan, and many more. Well, let's talk briefly about Web of Things. What kind of root is it? In fact, this is nothing more than the ability to integrate JavaScript ecosystem with various kinds of IoT devices. Thus, in a relatively short period of time, we can get a production-ready infrastructure using only what is given to us out of the box. And here is just a funny book cover that shows what the concept of Web of Things does look like. Okay. JS machine learning tools and what they are supposed to do. Speaking of JS Toolkit, there are several main and most active and prominent players worth noting. First of all, it's Tensorflow Js, the basis of all of the basics, solving a huge range of machine learning plus JS tasks. Secondly, it's Keras JS, an add-on over TensorFlow JS. It also allows you to use not only TensorFlow as machine learning backend if necessary. It basically allows you to slightly simplify the creation of neural networks based on upper level abstractions. ONNX, in addition to creating neural networks, also solve the problem of converting models into various formats, including its own ONNX. Say, if you have legacy machine learning project on TensorFlow, but you're a big proponent of PyTorch, you can use ONNX to convert TensorFlow representation to PyTorch compatible one. But what can we do if this is not enough for us? Well, time-hardened WebAssembly plus PyDit comes to the rescue, which is nothing more than Python translated into WASM format for use with any JS-compatible devices, and not to mention browsers. The very idea behind WASM is pretty simple. We take almost any programming language, and it doesn't matter at all whether it's compiled or interpreted. And let's say, as an example, using M scripting, we can convert it to WASM format, which in turn can be ported anywhere. The general scheme of work is as follows. We take any C, C++, Python, literally almost any programming language code, run it through M scripting, and the output is a binary WASM format, which we already import or connect where we really need it. Well, okay. What does it end up in terms of porting from Python? Well, it means that we can write almost anything in Python, even in a browser. And besides, ready-made libraries do not need to be manually rewritten in JavaScript. No doubt, WebAssembly is certainly great, but which of the pre-made options do we already have in the machine learning JavaScript ecosystem? In JS ecosystem, there are plenty of pre-made and pre-trained neural models that can solve problems of processing, recognizing, generating both images, and even streaming videos. ResNet and MobileNet is for the finding and classification of objects. Neural Enhance is for regular image-to-image conversion, pose estimation, recognition, and selection of the skeleton and contour of a person. And, oh, sorry for the mistake, it should be a lizard. Well, okay. Speaking of processing audio and text data, there are a huge variety of ML tools for natural language processing, translation of text, and recognition of commands from the audio streams. Well, we have already made models, but what if suddenly we need to port something new from the Python world? Here, Tensorflow Js Converter comes to the rescue, which works according to the following principle. First of all, you can convert Python model to JS only if all the layers inside are compatible with target model representation in JavaScript. Secondly, we are transferring the graph built on top of TensorFlow or Keras using TensorFlow Js Converter. Then the neural network optimization is performed for better browser loading performance. And in the end, we are ensuring that neural network prediction is kind of acceptable. Well, there are many of supported things, such as number of various CNN and RNN layers, different types of normalization and pooling, and many more. So let's take a look what kind of fruits are they and what they're supposed to do. Speaking of convolutional neural networks, it's simply just a class of deep neural networks most commonly applied to analyzing visual imagery. They are also known as shift invariant or space invariant artificial neural networks based on shared weight architecture of convolution kernels that scan the hidden layers and translation invariance characteristics. Speaking of recurrent neural networks, it's also a class of neural networks where connections between nodes form the directed graph along a temporal sequence. This one allows it to exhibit temporal dynamic behavior derived from feed-forward, which means that you do not have cycled connections between cells. Neural networks, recurrent neural networks can use their internal state to process variable length sequenced inputs. Speaking of normalization, well, the main idea behind the introduction of normalization is that if normalizing the inputs to the input layers improves learning, then obviously normalizing the inputs to the hidden layers will also improve the learning. Okay, speaking of pooling, worth noting that this feature is commonly used in conjunction with convolutional neural networks. The main idea behind pooling layer is to accumulate features from maps generated by convolving a filter over an image. And as an example, here is the process of max pooling, which extracts maximum from each squared region, performing construction of a brand new low-resolution matrix. Indeed, we have many tools. Now let's see how this can be applied to practical usage. Speaking of sentiment analysis, we can say that basically it's just a use of natural language processing, text analysis, computational linguistics, and biometrics to systematically identify, extract, quantify, and study affective states and subjective information. One of the most well-known datasets for sentiment analysis is IMDb dataset, which already has plenty of comments that are marked as positive or negative one. All right, that sounds good, but what about the business value? Speaking of business cases, we can easily name a few easiest to apply fields. First of all, it's reputation management. It can be really helpful with influencing on what and how people think of a brand or person when it's viewed online. Secondly, it's customer support with chatbots. And finally, applying these mechanisms to publicly available data, we can track our competitors and more quickly react on constantly changing circumstances. Well, imagine in our case, we have some kind of problem. To be precise, problems with comments moderation. So, indeed, there are plenty of comments that we need to handle. Secondly, people cost way more money than a machine. Usually it's problems with responsiveness. Human moderator may miss something. Potential claims and other issues between moderators and management, and so on and so forth. Another problem that we may encounter is the context. So, for example, exactly the same sentence, "it was incredibly unpredictable," can be interpreted in completely opposite meanings. Well, if it's applied to movie review, indeed, very likely we have positive sentiment. But for internet provider, well, it very likely will be having a negative one. And surely the business needs fancy yet informative charts to analyze the sentiment over the time. As a solution, we can use sentiment analysis tools to analyze all the feedback. So what do we do? Firstly, we are choosing the relevant Tensorflow Js neural network template. Then we are collecting all the needed data for training and testing. After that, we perform actual training and testing, and after all, we only need to simply plug and use this into your application. Okay, let's find the needed neural network architecture. As a basis, I'm going to choose a recurrent neural network as this one is a good fit for processing of any kind of sequence data. And as a refined implementation of RNN, I'm going to choose Lstm network because it simply allows you to have an efficient and flexible memory control since one word equals one Lstm cell. On the input of each cell, it forgets some part of the previous data that can be classified as less important for that particular moment. Then it produces and learns the new information, takes the previous result, superimposes with newly produced information, and then it passes the result to the next Lstm unit. Okay, the same, but step by step. At the first step, we get the result from previous cell and combine with the t-word through sigmoid function. According to current words, we learn new information and save it. After this, we are producing the memory for the next Lstm cell, and finally, we need to generate the output for this Lstm unit. Well, in this valve controls how much new memory should output to the next Lstm unit. And here, all in all, the whole picture of Lstm cell. And just in case, if you're the one who enjoyed the math representation, well, sure, no need to delve into this right now. All the materials and resources will be available by the link on the last slide. And here is Lstm training demo. Oh, just a second. Okay, what are these? This is a Google Colab. Actually, the place where you can put some code snippets and run them within Tails on Google Cloud Virtual Machine. So let's see what's going on over there. And start, we're loading the needed libraries such as TensorFlow, Keras. Then we are loading IMDb dataset and split the data for training and testing. And we are creating Lstm neural network. And finally, we start training. Well, it's gonna take a while. Let's skip a little bit this part. Okay. And when everything is done, we can see that after several epochs, the accuracy testing dataset goes up, but then it starts gradually falling down. Well, this problem is known as model overfitting, which means that this is the time we need to stop training as we start losing accuracy on potential real-world data. And finally, we are getting something about 84% accuracy on testing dataset. Here is just an example of positive sentiment recognition. As we can see, here we are using bidirectional Lstm model, which the simple Lstm that gradually forgets the context in the beginning. It reads provided text in both directions, from left to right and vice versa. which actually helps us to solve the problem with needless memory loss of what was happening in the beginning of a text. And an example of negative review. As we can see, here the neural network also recognizes the parts that have some positive meaning among the negative one. Okay, that's cool. Now let's see how it works on Instagram comments. As we can see, it successfully recognized and highlighted the negative, mostly neutral, and positive one. Well, it all looks good, but what about the inner implementation? Let's see. From high-level perspective, we have 4 phases. At start, we are loading and initializing our pre-trained Lstm model, and we are just collecting comments from a web page. Then we actually analyzing them using the neural network, and finally, we are simply coloring them. So during the initialization, we are just loading IMDb dictionary and initializing the model. Dictionary itself is just a list of words to vectors, since the neural network can work only with numbers and matrices. After this, we are loading the config of neural network, which says that we are using Keras with Tensorflow backend, define the embeddings, and so on and so forth. All right, the neural network is successfully loaded. Now let's grab all the available comments. Let's do this. In this part, we are just waiting comments to appear, and then using this tricky selector, we pick needed elements and extract the comments. And the most intriguing part of how we are actually performing sentiment measurement. So, in the beginning, we are mapping words to its number representation, and along the way, we are eliminating unknown and unsupported symbols. Then we are creating an input tensor and passing it into the neural network. And as a result, we get the probability if the text is a positive or a negative one. Well, after all, we are actually highlighting comments. Speaking of comments colorization, here is nothing particularly fancy. Hey, dude. We're just measure the sentiment of provided text, extract the degree, and then we are simply highlighting the element. And that's mostly it. But not really. In the end, I'd like to add just kind of a little fly in the ointment. A few words about possible pitfalls. Well, for now, it's much easier to train on Python rather than on JS, because Python ecosystem way more adapted for such sort of tasks. Secondly, it's pretty hard to convert Python to WASM manually. Of course, PyDit only provides core Python and some math libraries, but speaking of having TensorFlow on PyDit, well, the contributors say that they don't have much resources to perform maintenance of this thing. Currently, it's less convenient to do machine learning in Windows environment. Well, of course, you can use Windows System Linux to run Linux commands, but in general, Linux environment is way more preferable one. Sure, now it's really easy to start using pre-made TensorFlow JS models in your project, but if you need to understand how neural networks work beneath the hood, you need to be more or less familiar with statistics, probability, multivariate calculus, linear algebra. That can be pretty hard and boring in the beginning of your journey. But on the other hand, if you're already familiar with it, it should be pretty easy to understand. And as a result, we have steep learning curve as lots of abstract, at first glance, deep math is something that vast majority of people usually consider as tedious plus very boring to get to know. But at the same time, it's good because if you're already like a fish in water in this field, so in this case, you don't need to worry that machines will replace you in foreseeable future. And well, finally, let's sum all of good JS plus machine learning things up. First of all, it's convenient to use in conjunction with offline-first, highly performant and secure applications. Secondly, it's a wide range of usage on almost any device, web of things, etc. We have development prospects under the auspices of Google, Microsoft, Facebook, and other big corporations. And surely there is the access to browser API, whether it's microphone, web camera, Bluetooth, and so on. Thanks to all of you. Here is a link to all the information I used in this talk. Well, your questions?
We have a first question here, Artur. First one is, how fast is it in runtime?
In a runtime? You mean TensorFlow Js or PyDit?
The person who asked, it's Henry. He didn't add any additional details, just general runtime question.
Oh, well, it depends. From what I know, the PyDit, speaking of PyDit, it's not that good as it would be on the in the native implementation, because the PyDit uses SAM scripter under the hood. So in average, we get 9 times performance loss. It's not that good, but it's some kind of temporary solution. It should work. But speaking of TensorFlow JS, it's as good as your graphic card can do on your machine. But unfortunately, I cannot provide the precise numbers for now. But anyway, thank you for the question.
Actually, I think I can answer on that. I've been working a bit with TensorFlow JS also, and my data shows that for Intel GPU, I have a laptop with 2 GPUs, and for Intel one, it was compatible performance between WebAssembly code and GPU code, but I really didn't know how to switch between video cards with WebGL, so I wasn't able to attach my NVIDIA 1060. So I think it will be much faster, way faster. And actually, I was going to ask a similar question for you. about we have an influence of neural networks getting in browser. First there was ASM.js, then WASM, WebGL. There is coming WebGPU. What do you think? How much was the influence of these technologies? Which neural networks come into the browser if none of that would be here? Will it be boosted if we'll be able to connect VIDA cards to browser itself via web USB? What do you think?
Well, I think the neural networks are already with us. Speaking of browser part, because there are plenty of Chrome extensions that can do image processing. For example, they can do pose estimation things. For example, it also what else? It can do the text search. It can do some kind of text, say, when you need to zip a huge amount of text in several sentences, and also can do this thing. But sorry, the question.
The question, there was much questions in one. First one was about if none of these new technologies, these brand new technologies that make browser faster, make browser allowed to run faster code, would be here. We just were playing with old good DOM, maybe Canvas and JavaScript. Would the neural networks come later or the same way? Will it come faster if there will be new web GPU, there will be web USB with VIDA cards? I don't know.
I hope it will, but the future will show us what it will be.
And speaking about the not future, but nowadays, you told that there are several frameworks, several core frameworks. It's like Tensorflow, Onyx, there is also PyTorch. What would you pick on your own, and what would you advise to others? What was the best choice for you, and why?
Well, speaking of me, and I started from TensorFlow. Then I'm going to switch to PyTorch. And speaking of ONNX, it's kind of optional one. You don't need to just delve into the how it works before it's really needed in your cases. So simply TensorFlow, then PyTorch, and ONNX is the optional one.
From my point of view, yeah, it can be that way. As far as I'm disclaimer, I'm not a machine learning expert, but have a ton of friends that are working with machine learning in various cases, and they told me that TensorFlow was king of the hill like 2 years ago or so, but for now PyTorch is best choice. I don't know if it's true or not, but this is the opinion I heard.
I think so, because I also have machine learning friends, and they do and they use PyTorch implementation for now.
Mm-hmm. And what do you think? Is there a fight between JavaScript and Python on machine learning arena? I personally didn't know. I see that from one hand, guys that are working on Python and machine learning in general, they are just like, they're snobs. That's sometimes, and they are okay. These JS guys are playing with neural networks. Let them play, but they will come to Python. On the other hand, when they need to draw something, we cannot do this in Python. We need to go to JavaScript guys. And for me, it's a strange case that they either are looking from the top, and they have to use JavaScript when they need. But is there a fight or not? Or there is a synergy or friendship? What do you think?
Proper Python and JavaScript, I think there is no battle between them, because they mostly playing each own role in each own field. Of course, there are some intersections when the machine learning guys need to draw some charts, they usually use JavaScript at some extent, of course. JavaScript guys, when they need to do some machine learning, not just use the pre-made neural networks, when they need to train it, they would need to learn a little bit of Python. I think so.
And so you're speaking about JavaScript guys needing to use some machine learning, but why? Do you think that there will be, like, I don't know, AI in our favorite libraries like recurrent webpack, narrow React, convolution node? What will it be?
Well, I think that everything is gradually going to the direction of when machine learning mostly applies to using these tools, not some sort of weird Frankenstein libraries, because well, I think it's mostly because of separation of concerns. So the React, Node, Webpack will not likely become a Frankensteins. I think they will do what they are supposed to do, because machine learning and artificial intelligence should stay separately, and machine learning should be like a brain that does its own work using these tools. These tools should know nothing about machine learning in ideal scenario, I think so.
But Angular, React, Svelte, etc., they are all using now some algorithms inside that are predicting the way that will change the page. So maybe we'll have, for example, React engine that will predict how the page will change in the future, learning on the previous interactions. Maybe we'll have something like that. What do you think?
I think this is an interesting scenario. Yeah, maybe we'll be having something like this, but from what I know, in most cases, it will be like the machine learning will stay separately from the inner implementation of these tools. Of course, there can be some trade-off when for reconciliation or something like this, React can use these techniques in the future if it becomes kind of acceptable from points of performance and things like that.
So you're speaking generally that anyway, neural networks and AI are having the limits. They have a limit of usage, and they are useless in these places, or even bringing something bad. Can you talk about the cases when they are useless or not allowed or bad? Not speaking in JavaScript, not in frontend, but in general. Where are they bringing something not very good?
Well, speaking of this part, just the other day I've seen the news from European Union that they're considering to restrict AI usage while, for example, hiring new employees, doing some predictions in medical field and so on. I'll send you a link later. And also sometimes we can see that some neural networks, while they are providing the results, they do not explain why they deem that this is the actual solution. So you know that it can be at some extent dangerous in a medical field. For example, it's like, here is a solution. How did you come up to this one? I have no clue. It's not really good for now.
So you're speaking about a problem of explainability, right?
Yes.
And do you think we'll have a progress in future about that?
Because I think so,
I know,
yeah.
Yeah, I know that we have some steps forward and some models can be explained, but not in general.
Yeah, I think the future will show us how it also describes in very detailed way what they are doing and why they are doing. I think finally it should work for us.
But another models, not neural models, but for example, random forest or XGBoost, they can explain why they're making these decisions. Do you think that it's more sane to use them when you need to explain what you're doing, even if results are not so good?
I think it should definitely work. And also, I would add that Markov chains would also work because, well, while constructing the path to the solution, Markov chains can be kind of a good choice because we're kind of like, here is the possible ways of how it, just some abstract scenario, how it can work. The first way, this probability, the first one, and second, this probability, and combining these probabilities in the end, we can choose the most relevant strategy, for example.
Thanks. Hey everyone, we're waiting for your questions too, so if you have something to ask, you're free to ask it in the chat, so we are waiting for it. And for now, I think another interesting question is, what will be the next talk? What will we talk about next time? And when?
Well, not about when, not sure when it's gonna be, but I thought, I had a thought about the talk, which is kind of similar to this one, machine learning and dev security operations, kind of unleashing the power of security automation with machine learning. But currently it's kind of complex because most of the tasks are already handled without machine learning things like traffic analysis, detecting that that mining software is installed on your production machine and so on can be easily tracked. And well, I need to find the good things that machine learning can do and the usual tools cannot.
I personally got my brain shocked. It's more not a question but a story. On my current work at Raiffeisen, I'm integrating now one very specific APM platform. I'm not naming it because I don't want to make an advertisement, but it has crazy features because for now, with AI, they can make the indication of problem like, okay, we have 100 of users. Here's the list. When that are impacted by your problems, you have a conversion funnel, and they didn't reach the end of conversion funnel because of some errors that caused them a problem. They weren't able to load the URL of that kind. That happened because you have memory saturated for last six hours, for example, and this happened because of redeploy of new version of the Java application on that exact server, and they can easily calculate the impact, the user amount, the root cause, and this is a crazy level of machine learning, of prediction, and for me it looks like something of really next level. And what do you think? Will something of that kind come to exactly front-end problems, not integrated but something very specific for us?
Okay. In other words, the question is.
Reward. Do you think that there is or there will be or there can be some kind of very specific solution for front end that's with power of AI will be able to solve the problems and be like unfair advantage for front end developers that use it? specifically for front-end, not for back-end, because this system is working mostly for back-end. And for front-end, it's collecting only the user IDs and user and finals, but for servers, it's collecting the crazy amount of data and crazy amount of predictions. But I wasn't able to see the solution for front-end of that grade of AI.
No, kind of complex question.
Yeah, and what will it be able to do on your point of view? For example, analyze the stack traces all together and predict why they're happening, or etc. etc. I really don't know. It's mostly an idea because it's happening right now with me, and I wanted to just discuss it with you.
Not sure about that. There will be some very front-end specific tool, because machine learning, I think, should be, in ideal scenario, should be kind of flexible, because, for example, we can use machine learning algorithms to kind of count and rate the bugs that appear, say, in new release. So we can just easily prioritize them by severity, like critical, high, medium, low, something like this. I think it should go in this direction. So eventually we can automate things that usually are performed by manual QA, for example.
And have you seen the GPT-3 model that was trained on React? So you're starting to write what component do you want to get, and it creates a React code or HTML codes for you.
It sounds interesting. I haven't heard about in this scenario, but in common, I've heard that there is a tool that allows you to say a few words about your website, and it will construct it for you. I think this is also interesting direction to go for machine learning. It also can help front-end developers solving their just dull and tedious tasks. For example, some front-end engineers don't like much writing HTML, don't like much writing CSS, and for them it would be really cool that if there would be around some kind of pre-trained neural network that would do these things just like beep, already done in this way.
So why are you not afraid that we will be replaced? So AI will write the front-end code?
Well, mostly because of I started learning machine learning.
That's why you started.
Exactly.
Nice. I think we discussed a lot. We are waiting for more questions in our chat. It was a great talk, I think. But speaking for one last time, for one last question, what is inspiring you in machine learning?
Interesting question, because mostly machine learning is inspiring me because it allows me to do almost any kind of tasks automation. For example, the last inspiring thing I recently saw was that you can take a photo, for example, of a car, of some kind of object, and it can kind of easily translate it to three-dimensional representation. I think it's a really cool thing to do.
That's pretty crazy, yes.
Yeah.
Hi, Lina. How are you doing?
Couple questions, if you don't mind.
Sure.
So I'm a front-end developer. I know just JavaScript, HTML, and CSS. And Artur, are there any disclaimers for me if I want to deep dive into machine learning?
Well, first of all, it's kind of well, at some extent, you need to be warned that it's not that easy on the low-level representation things. For example, you need to be very, not very, just at some extent know that what is statistics, probability, linear algebra. You need to know how to do derivative of functions to find the extremum points. All of these things can simplify the process of learning of the neural networks. Well, it's not an easy one journey.
Sounds painful.
Yeah, it is sometimes, but in the end, you're getting the really, really cool results.
Actually, I was going to answer in a totally different way. It's not about how hard it is or how easy it is. I was talking with high-level guys that are like team leads in machine learning, etc., etc., and most of them are saying that 80% of people in machine learning, or even more, totally do not understand what they're doing. They're just taking the models, like we're taking NPM libraries or code from Stack Overflow. They're taking in a similar manner code from GitHub and archive.org from papers. They're copy pasting it and trying to make it work, and they're not diving into how it's working. It's just they're thinking, okay, I'll try it. If this will work, we'll take it. Totally not interested in how this is working, just making it work. And only like 10 or 20% are doing real science. And if you're thinking that you're doing something magical with CSS and HTML, and you do not understand why the flex is working this way, everything's fine. You know everything in comparison to 80% of machine learners. You're doing everything great.
Okay.
It's an interesting observation.
Okay, I heard Stack Overflow driven development, so yeah. My favorite way.
Exactly.
Artur, what was the hardest thing to you when you started doing machine learning? Like the hardest ever?
Well, it's interesting because, well, the hardest thing was that just 1.5 years ago, when I was not very familiar with Python, it was kind of hard to make it running within Windows environment. It was like a pain. I need to install Anaconda. This is an environment handling tool that allows you to load all the needed libraries and so on. Without this, I didn't know what I would do. I would need probably to manually remove and reinstall and over again different Python versions and so on. Yeah, and the second hard thing that, for example, I tried doing some machine learning on the pretty old laptop. I was buying it about almost 10 years ago. So there I don't have good GPU drivers, and some neural networks can be easily run off on such kind of machines. So it's pretty tedious to do this. But speaking of the convenient environments, I would choose Google Colab, because there you can use very cool GPUs, run it on Google Cloud machines, and do this for free. It's really cool, I think, in general, for some AI researchers.
Okay, I can relate to this problem with Windows because most of my working projects just don't launch on Windows, and I I had to switch to Ubuntu or something.
No, actually, it's not that hard. Speaking honestly, I have a Windows laptop, and I bought it specifically with Windows to have a NVIDIA GPU, and I used it for neural networks, and it was working fine.
Okay,
Well,
this is cool.
you're lucky.
Thanks.
Artur, do you use anything from your work in your real life?
For my work, for real life. Mhm. Usually, well, speaking of work, I'm working on the project which is called DaVinci Designer. This is a tool that allows end users to simplify designing of different greeting cards, booklets, so on. And for me, it's useful because I can just kind of design something and convert this really easily to PDF format, for example. This is a
Okay, great.
simple
So
use case.
it was a great talk and the interesting discussion, and we're out of time. And I suggest you to switch to the discussion room. And dear
Sure.
viewers, please join the discussion room too and ask Artur and Sarah about the talk. And guys, thank you one more time and goodbye.
Thank you, Lena.
Thank you.
Bye.